Hi Year 9, welcome to another exciting indices class. Let's get into it because today we're going to be looking at scientific notation. Now, scientific notation is the way we write really big and really small numbers. For example, if you were to look at this number here and try to fit it on your calculator, it wouldn't write it like that after you push equals because your calculator is only capable of writing 9 and 10 digit numbers, something like that. It's way too many digits. So what we do is we actually look for the first number. Well, actually, before we actually talk about it, just put them into your calculator. If you put those numbers into your calculator, these are the answers that you get. This is a really big number. And so we get times 10 to the power of 21. That 21 means there are 21 digits after this decimal point. So between the 1 and the 2, you should be able to count there are 21 numbers or digits after that decimal point that I've placed there. When you've got a negative power, it's a way of writing a very small number, 0.0000 and so on. So there are 22 numbers to the left of this decimal point. So if you go between the 4 and the 7, there should be 22 numbers going to the left until you find the next decimal point there. Let's see if we can make a bit more sense of it by actually following some instructions. First thing, sometimes scientific notation is called standard form, and we use it to write big and small numbers. What we do is we put the decimal point on the right of the first digit that is not 0. Then we count how many decimal places that position from here is from the original decimal point in the question. Then we write after the number that we've got times 10 to the power of however many positions the decimal place moved. If you've got numbers smaller than 1, they've got a negative power. If you've got numbers bigger than 1, they've got a positive power. And you can use scientific notation on your calculator, and we'll talk about that later. Old scientific calculators, looks a bit weird when you see scientific notation, but you don't have to worry about that because your calculators write it in the proper form. Okay, let's try it. Now remember I said to write a number using scientific notation, and we're just using a pretty small number here, 587 fits on the calculator screen, but we're learning the process. The first thing you have to do is put a decimal point after the first number that's not 0. So the first number that's not 0 is 5, so we have to put a decimal point in between the 5 and the 8. So it becomes 5.87. Now, originally 587 is the same as 587 point nothing. We've put the decimal point in between the 5 and the 8. So hopefully you can see that there are 2 numbers or 2 digits between where the decimal point was originally and where I've moved it to. So what we do is we go 5.8 times 10 to the power of 2 because the decimal point needs to be moved 2 places to the right to go to its original position, which was 587 point nothing. Let's try the next one. We have to write down the first, or have to put the decimal point between the first digit after the first digit that's not 0. Let's get that right. So it's 2.8. Now you could write 2.8 nothing, 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 but when we're writing decimals, if there's zeros on the end, we don't bother writing them, so we're not going to worry with that. So 2.8. Now the decimal was originally here. We put it between the 2 and the 8, and there are 1, 2, 3, 4, 5, 6 numbers between those 2 decimal points, so we'll write times 10 to the power of 6. Right, we need to put the decimal point after the first number that's not a 0. And the first number that's not a 0 here is the 5. So we go 5. And we could write 5 point nothing, but we just write 5 because there's nothing after the 5, times 10 to the power of. Now, let's have a closer look. The decimal was originally here. We've put it after the 5. We just didn't write 5.0. And there are 1, 2, 3 numbers. But this is a really small number because it's 0 points, so we put 10 to the minus 3. Remember, the power will be positive if your original starting number is bigger than 1, and the power will be negative if the original starting number starts with 0 point because it's a decimal, small number. Let's go to part D. I need to put the decimal between the 1 and the 2 because that's after the first digit that's not 0. The decimal was originally here, so there's 1, 2, 3, 4 numbers that we've got between those 2 points, so it's 1.23 times 10 to the minus 4. We continue on. Let's try writing in decimal form now. So this is a number that's written in scientific notation. Here we're told that the decimal needs to move 2 places to the right. So if I move the decimal 2 places to the right, that number is 567.8. And there's my answer. Because really, times 10 to the power of 2, that's 10 squared is 100. We're just timesing by 100. Timesing by 100 moves the decimal 2 places to the right. This time I'm going to move the decimal 7 places to the right. Now remember, this question could be considered as 2.34500000000. There's just an infinite number of zeros there. And I want to move the decimal 1, 2, 3, 4, 5, 6, 7 places to the right. So that's where I want to put it. So when I do this, I count out my 7 places and I put the number in. And so if you actually look at it, originally the decimal point was between the 2 and the 3, and there are 1, 2, 3, 4, 5, 6, 7 numbers after where the decimal point was because it's 10 to the power of 7. So if you don't have enough digits on the end, you just put zeros there. Let's try this one now. Because this is the power of minus 2, the decimal point's going to go left because this needs to be a smaller number. So what we need to do is consider this is really 0.009 point. Just put some zeros out the front. We're going to move the decimal 2 places to the left. So let's move them 2 places to the left. That's my new position for the new decimal. And I don't worry about writing that anymore because that just was the instruction to say move the decimal 2 places to the left. There's my answer, 0.09251, which is a small number. Again, because it's a negative, I'm moving the decimal to the left. So I'm going to put some heap of zeros in front of that 2 and move 1, 2, 3, 4, 5, 6, 7 places to the left. That's where my decimal has to go. And then I can cross that off because that's the move the decimal instruction. And there is my answer. So hopefully you're starting to get an idea of how scientific notation works. Time for you to try some questions. Enjoy the wonderful experience. Bye for now.